Welcome to a lesson on the 6 basic trigonometric integral formulas. In the previous video we saw how these integral formulas followed from these derivative formulas on the left-hand side. However, notice that these integral formulas are missing 4 of the 6 basic trig functions. We have an integral formula for cosine x and sine x, but not for tangent x, cotangent x, secant x, and cosecant x. So in this video we'll see where those formulas come from. But before we do that, let's go ahead and review the log rule for integration. Remember, if we have the integral of 1 over x dx that's equal to natural log x plus c, similarly, if we have to perform a u substitution, we would use this formula here. Now the reason I want to show you this now is because if we do take a look at the 6 basic trig function integral formulas, notice that the remaining 4 formulas do involve natural log. So in this video we're going to focus on where these last 4 formulas come from and why the natural log occurs in the antiderivative. So for example, here's the integral formula for tangent u du. So let's see if we can determine the antiderivative of tangent x dx. Remember, tangent x is equal to sine x divided by cosine x. So if we take a look at this integral as a quotient, and we let u equal the denominator, so u would be equal to cosine x, then differential u would be equal to negative sine x dx. Notice that we do have a sine x dx in our integral, so I'm going to go ahead and solve this for sine x dx. So we'll have negative du is equal to sine x dx. Now let's go ahead and rewrite this in terms of u. So sine x dx is equal to negative du and then we're left with 1 over cosine x, but cosine x is equal to u, so we would have 1 over u. Well, the antiderivative of 1 over u is just natural log u, so we'll have negative natural log u plus c, but u is cosine x, so we have negative natural log absolute value of cosine x, which matches our formula for the integral of tangent u du. Now for the formula for the integral of cotangent u du, if we take a look at the integral of cotangent x dx, it's going to be a very similar process. We know that cotangent x is equal to cosine x over sine x. So if we let u equal sine x, du would be equal to cosine x dx. And we'd go through the same process that we did on the previous screen for the integral of tangent x. I'm going to go ahead and stop here, but you may want to verify this for yourself so you can see where this formula actually comes from. Let's take a look at the integral formula for secant u du. And this one does tend to be a little bit trickier. If we take a look at the integral of secant x dx and then multiply it by secant x plus tangent x over secant x plus tangent x, remember this is like multiplying by 1. And you might ask, well, how would you know to do this? And well, you probably wouldn't, but let's just go ahead and see what happens when we do this. So multiply the numerators together. We'll have secant squared x plus secant x tangent x all over secant x plus tangent x. Now again, if we set the denominator equal to u, let's see what happens. So differential u is going to be equal to the derivative of secant x, that's going to be secant x tangent x, plus the derivative of tangent x is secant squared x dx. And this works out great because notice that our numerator, secant squared x plus secant x tangent x dx, matches differential u perfectly. So all of this highlighted in green just becomes du, and secant x plus tangent x is equal to u, so we have 1 over u. So this gives us natural log absolute value of u, where u is just secant x plus tangent x. So it would be difficult to know that you had to multiply secant x by this fraction here in order to make this work. But really, as long as we know that it does work, we have a better understanding of where this formula comes from. And if we want to consider the formula for secant x dx, as we see here, it's a similar process. I'm not going to go through it, but what you'd have to do is multiply cosecant x times cosecant x plus cotangent x over cosecant x plus cotangent x. Again, this is equal to 1, but if we multiply this out and let u equal the denominator, we will end up getting the formula for the antiderivative of cosecant u du. And you may want to try it so you have a better appreciation for this formula. We're going to go ahead and stop here on this video. We'll take a look at some more examples in part 2 and part 3 using the 6 basic integral formulas. I hope you found this helpful.